Wow. Welcome to the last module in mathematics course. Thank you for staying committed. Thank you for staying focused. This module 10 is about probability. So this module introduces probability, and it is a mathematical study of uncertainty. Life is full of uncertainty. Life is unpredictable. So it's a mathematical study of uncertainty and likelihood. So in this module, you will come across topics like events, outcomes, sample space, experimental and theoretical probability, equally likely events, mutually exclusive and independent events, and the laws. So practical examples are also there, and it covers business, sports science, technology, and agriculture to show how probability can support decision making and also risk management. Now let's look at some of these definitions. What is an event? An event is an outcome or set of outcomes from a trial. Each trial is a single attempt. An event is what occurs. It is often denoted as E. So when you hear event under probability, what is referring to is outcome. What is the outcome of the trial? The other point you need to take note is random experiment. Random experiment simply means a repeatable process that may produce different outcomes. For instance, if I toss a coin, or I roll a die, or I play card draw. Okay? Then there's what we call sample space. Sample space is just the set of all possible outcomes of an experiment. So that is what is called a sample space. So, for instance, if I throw a die has six faces. If I throw a die, my sample space is 6. It cannot be 100. Okay? So the number of elements in a sample space is ns for an event, ne counts for favorable outcome. So sample space is just all the possible outcomes of an experiment. Now let's look at the difference between equally liked outcomes and their formula. Okay, 2 or more outcomes are said to be equally likely when each has the same chance. For instance, die faces. Like I mentioned before, it is 6. So if you throw it once, you have 6. If you throw it more than once, that is when you increase. So the probability of event PE is NE all over NS. NE, don't forget, E is event and NS is sample space. So probability values range between 0 and 1. The complement probability is P, that is not E, will always be 1 minus PE. So let's start from example, a die example. In a die, the sample space include 1, 2, 3, 4, 5, 6. Each outcome, if I throw a die once, I will have 1 of 6, 2 of 6, 3 of 6, 4. So each outcome will be 1 over 6. So that is what it means. Now let's look at the difference between experimental and theoretical probability. Experimental probability is based on observed outcome from trials. When you practice something, so you are trying to experiment. For instance, if I throw a die or toss a coin, a die rolled 200 times produce frequencies for faces. If I roll a die for 200 times, there will be many frequencies of the face. So it will now be observed 6. If I say, okay, let's do the probability of having a 6, it will be all the observed 6 all over the total number of times I threw it, which is 200. At the end of the day, you have 32 over 200, which is 0.16. The order of theoretical probability. This assumes equally likely outcome just based on reasoning about the situation. For a fair die, P6 will always be 1 over 6. So experimental and theoretical values may differ due to sample variation. For instance, let's look at this. If a first 6-sided die is thrown, what is the probability of having prime numbers? So in it, you will see how many prime numbers can you see? 2, 3, 4. 4 is not a prime number, but 2, 3, and 5. So that 2, 3, and 5. So how many? That's 3 is the event or the outcome all over. What is the total number of sample space? 6. So it will be 3 over 6, which is equivalent with 1 over 2. You can also calculate number less than 4. If you check how many numbers are less than 4, 1, 2, 3. So there are 3. So the probability of having numbers less than 4 will be 3 over 6, which is the same thing as 1 over 2. What if you are asked to calculate the probability of having odd numbers? 1, 3, 5. What will it be? It will still be 3 because there are 3 odd numbers in the space. So what of perfect squares? We only have 2 perfect squares, they're 1 and 4. So it will be 2 over 6. So that is how theoretical probability is carried out. Now, let's move on to mutually exclusive events. Mutually exclusive events are events that cannot occur together. The probability of A or B, either or, is P of A or B, right? When A and B are mutually exclusive. So use the addition law for questioning or for questions containing OR. For instance, a bag with 3 red balls, 4 blue, 5 white, and 6 black. What is the total number of balls? Is it not 18? It is 18. So the probability of picking a red or a blue will be, what is the total number of red? 3. Then the total number in the space is 18 plus, because when it is all, you make use of plus 4 over, that 4 is blue, 4 over 18. At the end of the day, you have 7 over 18. What if you are asked to calculate the probability that it is neither red nor blue? That will be 1 minus, that's total, 7 over 18, which will give you 11 over 18. So independent event, don't forget I talked about mutually exclusive event in the previous slide. So independent events do not affect each other. Whereas in mutually exclusive, the occurrence of one affects the other. So independent events do not affect each other. The probability of both A and B occurring is P bracket A and B. All right. So use multiplication for and or both and. For instance, a coin is tossed. A coin is tossed. What is the probability of having a head? Now, the sample space for a coin toss is just 2. So the probability of having it is 1 over 2. That's it. So follow carefully. What if you are given this example, a bag containing 3 black and 2 white balls with replacement? How do you solve it? First, you have to take note the total number, which is 5. So what is the probability of the one that wants black? It will be 3 over 5 times 3 over 5, which will give you 9 over 25. Then the probability of one black or one white will be 12 over 25. So the probability of at least one black will be 21 over 25. So you can select number from a figure, all prime evil divisible by 3, perfect square, etc. So we'll now use it to do our calculations. So let's look at application of probability. Probability is very applicable in business because probability quantifies product failure or market success. Example, 50 failures out of 500 launches. The probability of failure is 0.1, that is 50 over 500. So insurance use past data to price premiums and manage risk. Let's look at its application in sports. Coaches use player success rates to inform strategy. If a free throw shooter makes 70 over 100, which is 0.7, for the next shot, decisions exploit such probabilities for tactics. What of in science and technology? We mentioned experimental probability. So it can be used to predict outcomes. Because 50 over 100 bacteria responded. So what is the probability? 0.15. So in AI, model accuracy informs deployment and reliability planning. What of agriculture? Historical rainfall in 8 of 10 years, the probability of adequate rainfall will be 0.8. The probabilities of guiding planting, irrigation, and pest control decisions to reduce uncertainty. So all these are the applications of probability. So in conclusion, Module 10 equips students with tools to quantify uncertainty. It equips you with tools to define event, build sample space, computing experimental and theoretical probabilities, and applying addition and multiplication laws for mutually exclusive and independent events. Mastery enables informed decision making across business, sports, science, technology, and agriculture. So you have to note these applications. Okay, so probability is not just a mere topic taught in schools. It has applications, so it can be is applicable to uh, to a lot. So if you look at it again, after this module, you will see assessment. So assessment is inclusive. I'd like you to go through the assessment. In the module, you see different soft calculations. So you practice your hands on them, and also take the assessment. Thank you for listening.